So let's go directly into. You're going to see a problem similar to this. I'm not going to draw this for you guys tomorrow. You're going to be able to draw that. I'm going to describe it for you, and you need to be able to draw that diagram and do the calculation. So here's what we have. We have three lights, light A, B, and C, and we have 3 points, point 1, 2, and 3. And I'm going to ask you to do the calculation at the 3 points, or 1 point maybe, or 2 points. Cool? So I'll give you a few seconds here to do them. All these lights are coming, the diagram for them are coming from Fig 5.3, page 50. And that's the same Fig that you're going to use tomorrow on the test. You're going to be using the same figure. So when it says go to Fig this, you're going to open your book, Andrew, my friend, to that page, only that page, and get it. So that's how we're going to do it. One more time. I have 3 lighting fixtures mounted on a 10-foot poles, spaced 20 feet apart. Can you see that? With a guarding factor given of 0.88, right? And I need to find, what's my job? My job is to find the lighting contribution at each and every one of these 3 points from all the 3 lights. Everybody got that one? We did a problem very similar to this. Cool. Give you a few seconds to write them. So then, if you can see, if we're looking at the contribution at point 1, for example, there will be some coming from A, some coming from B, making an angle of Q1, some coming from C, making an angle of Q2. Everybody can see that? And if we're looking at point 2, there will be some from C, making an angle of Q1, and same thing, Q1, similar because similarity. And so there's a lot of symmetrical triangles here. So you're not going to do all the calculation. Remember how we took advantage of the symmetrical triangles? Okay. Shall we do them?
What was CP again? I forgot.
CP is candela power.
Oh.
These are the lumens. The candela power, the lumens. Okay, so I'm going to let you guys give you a few seconds here to write them. And then, so, the way we handle a problem, now remember, Aaron, I'm not going to draw this for you tomorrow. It's going to be described. So when it describes 3 fixtures at 3 points, I expect you guys to draw this, right? And draw exactly what I'm doing and contribution for each one of them. Can I have thumbs up, Chad? Yes,
You're just going to give us the 10 feet to 20 feet.
Yep, I'm going to tell you I have 3 fixtures mounted at a pole of 10 feet and spaced 20 feet apart in 1 row. Find the contribution at point 1, 2, and 3. So you have to draw that, right? Can I have thumbs up, Chad? We draw it exactly like this. Yeah, I have to give you that one. Yep. The GF will be given, and the height will be given, the space between them will be given. Otherwise, good luck. I mean, you can't. The formula, this is the formula you're going to use. Bring it with you. If you memorize it, great. If you bring it with you, I'm okay with that. I don't want to see the example in front of you, please, though. Okay, shall we go do it? So let's go. So the first thing I want to do at point 1, this is point 1. Okay, at point 1, I have from fixture B at point. What am I going to do here? Okay, the first calculation I'm going to do at point 2 actually. From fixture B at point 2. That's my first calculation I want to do. Are you okay with that, guys? From fixture B at point 2. And everybody's okay with this? Well, I'll see. Got it. Huh. The candela power based on the angle and all coming from where?
Okay, so we don't. Do you want us to look it up in the book?
Yes.
The test?
Yep. It will say to tell you go to this page.
Okay.
Yep. Otherwise you can't do it. All right. So let's go ahead and do it. Foot candle equal. What's the guarding factor? Well, before we do it, we go ahead. Let's find the angle first. We need to find the angle. So what's the angle? The angle right underneath from B to 2. 0. So I'm going to call this is Q or theta. QB equals 0. Everybody understand why? right underneath it. And from here, we can take cosine of 0 is what? 1. That's straightforward. That's the first thing you need to do, right? Right underneath it. Cool. Then plug in the numbers, will ya? So let's go ahead and plug in my numbers. So foot candle equal, what's the guard factor? 0.88 times candela power at 0. Where's the book? Go to this page, will ya? Candela power at 0, page 50. That will get you 949. Everybody knows where the 949, that's the candela power at the angle 0. Multiplied by 1 raised to the power 3. Everything here is divided by the height, which is 10 raised to the power 2. And if you guys did your math right, you should come up with 8.4 foot candle. 8.4 foot candle. Done. Aaron, my friend, do you know why we came up with 0? Because right underneath it. What's cosine 0? Always 1. Where did the 949 came from? This is from Fig 5.3, page 50, based on an angle 0 for this particular fixture. Make sense? Piece of cake. But can you guys see this is contribution from B to 2? Now, let me ask Darren, anybody else, what do you guys think contribution C to 3 would be? Identical. How about contribution A to 1? Do you need to even do the math? So you see how the symmetry can take care of most of the calculation? Let me know when you're done so I can flip. So, okay. Now next, the next one, look at the contribution. And by the way, do you have to do them in this order? You can do them in any order you want. This next one I would like to find from fixture A at point 2. Let's look at fixture A to point 2. Here's fixture A, here's point 2. What's the angle? Q1. I need the Q1. Can you guys see? Here's point 2, fixture A. It's shooting this way. So I need to find, the first thing you need to do is find the Q1. Then you're done, right? From Q1, you can find the candela power and plug them in. Everybody understand? I'm calculating now from A, we did B to 2, I'm going to go A to 2. Now, Derek, do you understand? Do you see that also C to 2 is going to be identical? So I don't have to do C to 2 because it's identical. Okay, let's go to do A to 2. From A to 2, the first thing we need to do is Q. I need Q, I call this as Q2, or Q, let's call it Q, what are we going to call it? It was a QA2, I don't know how many, A2, basically coming from A to 2, right? QA2, coming from A to 2. This will be, do you guys remember how? Tan Q equal tan Q. This is what we need to find. Now tan Q equal the opposite over the adjacent, right? You guys remember that triangle? I need to find the tan. Look at this. Here's the angle. Tan the angle, the opposite, which is 20 over the adjacent 10. Everybody can see that? Opposite over adjacent. So tan Q over equal basically 2 here, right? Equal to. Then the next thing you need to do is which angle tan 2 inverse, tan inverse 2 equal, which angle has that tan over 2? So that will give you a 63.4 degree. That's my angle. Then you do the piece of cake. Now the foot candle equal. Now you plug him in, right? Now you plug him in. One more time. Everybody understand why I took the tan, not the sine, not the cosine? Because the tan is the easiest to find. Opposite over adjacent. Do I know the opposite? Yes. Do I know the adjacent? That's the height. Okay, that's why we really picked up the tan. We could have picked up the sine or the cosine. Okay, now plug in the formula, will you? So the guard factor is 0.88 multiplied by, okay, candela power at 63.4 0.4. Do I have 63.4? So I'm going to go to the closest. Okay, 63.5. If you guys go there, 63.4. I don't have 63.4, so I'm going to go to the closest, not the highest, not the lowest, the closest. My options are going 50, 55 or 65. Which one do you guys going to go? 65. So I'm going to go, what's the contribution 65? 780. Multiply this. Though I continue to do cosine 63.4, that's an approximate value. And you're going to square, cube everything, divided by the height is what? 10 to the power 2. And
cube everything or just cube cosine 63?
You cube cosine the angle.
Okay.
Yeah. Cosine the angle, not everything. Cosine the angle. And that will give you 0.62. 0.62. You can see not a whole lot because we're far away from it. We're far away from it. The same thing, guys, I said from fixture, believe it or not, this is a fixture. From fixture C at 0.2, symmetrical, so that will be also what? Foot candle equal 0.62. Can you guys see that? Everybody understood why C to 2 is the same as A to 2?
No.
You don't have to do the math on that. Any comments, any questions, guys, about this? So we find from A to 2, from A to 2, B to 2, and C to 2. Are there any other fixtures? No, 3 fixtures to 1 point. So let's go now. You want to find the total foot candle at that point. What do? Add them up. Add them up. Any comments, any questions before I go add them? So I'm going to go add them up. Everybody can see what we did. We found the foot candle from B to 2, A to 2, C to 2. Now I want to add them up to find the total one. That's at 0.2. So let's go add them up. So total foot candle at 0.2 from A, B, and C fixtures equal the following. I have 8.4 plus 0.62 plus 0.62 equal, I have 9.64 foot candle. That's the total foot candle at 0.2 from the 3 fixtures. Okay. See how that's now we calculated. The first set of calculation is to find at 0.2. Why did I pick 2, not 1? Because it's easier to do 2 first, and then I want to go to 1 in a second. Is it wrong if you start calculating at 0.1? No. Okay. So that's it. That's at 0.2 when you guys are looking at 0.2 right here. Here's 0.2. Now I'm going to go find the calculation at 0.1. Now before I even start, do you guys agree with me that if I find the calculation at 0.1, everything, it will be identical value at 0.3? Just from symmetry. Do I need to even do it at 0.3? No. If you find the calculation, the total, overall contribution at 0.1, it's exactly identical to at 0.3. Why? Because his contribution C to 3, B to 3, and A to 3. This is identical to A to 1, B to 1, and C to 1, right? So if I do it at 1, I'm done. I'm done. I don't have to do 3, right? Because of symmetry. Okay, so that's a major symmetry. Okay, then from fixture A at 0.1, haven't we done that? A at 1 is exactly the same as what? B at 2. Yeah, so I don't have to do the calculation for this one, thanks God. So I'm going to say this is foot candle equal 8.4, and this is why symmetrical as in B at 2. Symmetrical with B at 2. as in B at 2, right? Exactly the same. When we did B to 2, symmetrical with B to 2. That's piece of cake. All right, so how about from fixture B at point 1? Do I need to do that? B at point 1. That's exactly like A at point 2, right? Symmetrical. So that calculation is done for you. So foot candle equal 0.62. See how the nice thing is? And this will be also symmetrical. Symmetrical with, let's say with here, with point with A at 2. Oops, A at 2, right? If you look at the triangles, symmetrical. So these are done for you. These are done for you. You only have to do really one calculation for that stuff, right? From this is from point 1, fixture B at point 1. We're going to do C to 1 now. C to 1 is different because they're C at the other end. C to 1 is different. Let me know when you're done with this one so I can move. We good? Oh, sorry.
Yep.
Everybody's good? Is Jeff the slowest kid in the classroom here? Oops, sorry, Jeff. I have to pick on you. No, I don't. Oh, the only one who cares. No, you guys all care. Okay, here's the from fixture C at point 1. Do you guys remember? I'm going to just draw. Here's one fixture, and there was another fixture here, and a third fixture here, right? Well, let's just say the fixture here, right? So and that was 20, and that was 20. When you add them up, they'll make it 40. That's the only difference. So I need to find, that's the only difference from 1 to this point right here, which is from fixture. This will be point 1 here. This will be fixture what? A. A, B, C. That'll be fixture C. This is A, and this is B, right? See that contribution? So from fixture C at point 1, let's go do it. What's the angle? Because the only, really, so the first thing I need to go is tan Q2. Do you see what Q2 here? Equal the opposite over the adjacent. So 40 over 10 equal 40 equal 10, which is 4, right? Then tan inverse
75.96.
thank you, tan inverse 4 equal, let me see if I came up with the same thing. What did you come up with?
75.96.
96, that would be 76. Would that hurt your feeling?
Yes.
76. Okay, then you're gonna start plugging him in. See how easy that is? Then foot candle equal 0.88, the guard factor. Now, we need to find the candela power at 76. Do I have a 76? What do I have? I have 75. The closest is 75, so take it 75. That will get you 194. Multiply this by cosine 76 raised to the power 3. Divide everything by 10 raised to the power 2. And that should give you a healthy, well, a healthy nothing almost. A healthy 0.024. Do you see, Jeff, the further away you go from the point, the more you can start ignoring the contribution of fixtures. It starts becoming nothing, man. 0.04, wow, that's nothing, right? 0.024 even. Do you see how the further away, obviously, the fixture is, the less contribution is going to get at that point. Okay, so that's it. Now the total for the three of them together the three of these fixtures together, add them up, total from A, B, and C at point 1, 8.4 plus, I have 0.62 plus 0.024 equal, I have 9.04. 9.04. The last thing, from fixture A, B, C at point 3, did you guys told me it's the same? Right? So what do you guys think it's going to do? I need to do the calculation for 3 and go through the whole hassle?
No.
I can easily see 9.04 done.
But we have to write that it's symmetrical, right?
Yeah, you have to tell symmetrical relation.
All right.
Yeah. Cool. Any comments, any questions? Any comments, any questions? Okay. The last thing I want to do, guys, I'm going to be here. I want to do one contribution vertical. Remember that we did the vertical one? I want to do one vertical one. 1 point vertical and done. Promise. One contribution vertical done. Okay. Let me know when I can move on. Move on, Chad. Yes, no? Move on? Okay. So let me go directly into here. Here's the problem. This is question number 2. I have a vertical line like this. And I have the same fixture mounted at the same height, 10 feet. And this fixture is shooting right in here. Okay, and the distance is 1 foot from here to here, 1 foot. Cool. And I would like you guys to find the contribution from this fixture right at 1 point. You can find it at any point, but right at this point, which is from here to here, is 5 feet. Right at this contribution. I'm going to call it, this is fixture A. This is, I'm going to call this one point 1. Fixture A, point 1. I need to find one fixture, vertical surface, contribution from that fixture, the same fixture, with a guard factor of 0.88. Same fixture, same fig, everything. Fig 5.3, 5 point, oops, might as well erase it. 5.3, 5.3, page 50. Same thing, except I have a distance of 1 foot here, from here to here, from here to here, 1 foot. Cool. I need to find the contribution in this vertical wall. Can I, this is like a face of a switch gear. Can I read the stuff on the face of that switch gear, the meter? That's what the application was. All right, so let's go write the formula first. The formula, if you guys remember, that we use for, this is foot candle V. Anybody can tell me what V stands for? Vertical, thank you. Foot candle V, guard factor times, anybody? Candela power times sine Q, the angle, over the distance, D squared, over the distance squared, over the distance squared, over the distance squared. So guard factor, CP, sine, no square, nothing, divided by the distance. Okay. So we're going to find it at point 1. So here's the angle that we're trying to find, guys. This is Q1. I'm going to call this angle is Q1. Right? So let's find the angle first. So to go ahead and find the angle for us, we need to find the angle is the opposite. So tan U tan Q1 equal. What's tan Q1, guys? This is 1 and this is what? 5. What's tan Q1? The opposite over the adjacent. What's opposite is 1 over the adjacent is what? 5, right? Opposite of what's this is the tan of an angle. Okay, so that will give me what? 0.2. Then I need somebody, I don't have the answer for this. Tan Q of tan. So then you would say Q1 equal tan inverse 0.2. Anybody can give me a tan inverse 0.2, please?
11.3 degrees.
How much?
11.3 degrees.
11.3 degrees. Anybody can second that? Second? Okay. 11.3 degrees. Very close. Can you guys see it's very close? Okay, now what's the oops, there you go. What's the contribution at 11.3, guys? What's the contribution at 11.3 from that? So the rest, guys, is history. Then we can find foot candle equal 0.88 times. What is the contribution at 11.3? Which one is my option is to go to 5 or 15. Which one do you think is going to go? 15. So it will give you 1094, right? 1094 times. I need sine. What is the sine of 11.3 degree? I need somebody to do that one. Divide this by the distance. Oh, we didn't find the distance. So the distance, D equal here. This is Pythagorean theory, guys, if you remember. So that will be 1 squared plus 5 squared. So a square root of 6. What's 6, Chad? A square root 5 times 5 is 25 plus 1, 26. 26. Can somebody give me the square foot of 26, please? What's the square root of 26? Everybody knows how to find D, the distance here? We need to find the D, distance. Square, everybody knows what Pythagorean theory is? Square each side of the triangle, you find the hypotenuse. Square, how much? 5. 5 is good. 5 is good enough for me. 5. Okay. Let's say let's do it for it 1 because
5.099.
so 5.1 just to be slightly different from the other side. You can see it's okay. So then this will be 5.1 raised to the power of 2. I need 2 gentlemen to do all this for me and give me the answer right on the spot. Then we're done. And they have to agree on the answer. Where are my favorite students? Did they leave? Carrie, give her a shot. 37. Point something? 0.7. I need a second and a third. Who is the second? State your name, sir, for the record. 37, okay. Who's the third? Where's my third?
I screwed up.
Maybe that screwed up, Brian. So any third? Brian? You can go to jail if you say third without approving your name. Okay, 37. Anybody else came up with something different? I hate to use my calculator, come up with something different here.
I got 7. Same. Actually.
7?
Yeah, 7.2.
7.25, see? 7.25.
So I was right.
7.2, you are always right. 7.25, 7.3.
I thought I didn't know how to use a calculator.
7.3, 7.3, 7.3, 7.3 it is. That's what I thought. It's a little bit high. Okay. What did you do, Kerry? What was it? Okay. Instead of squaring it? Okay. That's the mistake that could happen with the test, guys. So please be aware of that. Gentlemen, you do this. You review the questions. You get your A's with your friend Chad. Otherwise, we'll see you in the fall of next year. Okay. That's all I have for you guys. I'm hoping that you guys will continue working on your lighting, emergency lights, energy code in the last hour left here or so. That's it. Thank you.